Hello, Shannon Windsor here, and I'm really excited to talk to you today about cell danger response theory. So, this is something I've actually been wanting to talk about for a while because it is absolutely fascinating. So, the majority of work that's been done on cell danger response theory is by Bob Nobile. So, you can by all means look him up and look up cell danger response theory because you're going to find that it is just so fascinating. And my goal is always to encourage you to become curious and to want to do more research or find out more information. So go ahead and dive in and check him out. I myself actually was introduced to his work, or it was brought to my attention by Dr. Jay Davidson and Dr. Todd Watts from Cellcore at an eco conference that they shared. So I'm excited to bring this to your attention and see if it helps piece some of the puzzle together for you. So before I really dive into cell danger response theory itself, I want to address some really important steps surrounding our mitochondria and our mitochondria function. Might be taking you a little bit back to biology 11 or 12. Sometimes I wish I paid more attention in biology 11 and 12 because it all pieces back together now. We often speak about healing on a cellular level, but what we're really speaking to is a mitochondrial level, right? And the mitochondria are inside the cell, they're intracellular. So that's really what we need to focus on when we're talking about healing our bodies. Most of our cells actually have between 1,000 and 10,000 mitochondria, which is a huge difference. But cells like a single neuron in the human substantia nigra has estimated about 2 million mitochondria per cell. The oocyte, or the female egg, which was once thought to have the highest number of containing mitochondria, is estimated to be about 100,000 mitochondria per egg. So that gives you a bit of an idea how many mitochondria we're talking about in one cell. So mitochondria are found in all of our cells except for our red blood cells. So this is actually is key for later on when we're going to be talking more about this. We have about 5.1 trillion cells containing mitochondria. So we have about 24.9 trillion red blood cells, but remember, mitochondria are only in non-red blood cells. So we're talking about all non-red blood cells, right? So that's about 5.1 trillion non-red blood cells times about 2,000. If we take sort of a middle factor there, maybe 2,000 mitochondria per cell, then we're looking at about 10.2 quadrillion mitochondria in total, which is, it's amazing, and something that I feel like this is so important for us to dive into further is really understanding our mitochondrial function. So a key point to remember is that as we touch again on this later, we need to know that the mitochondria are always intracellular unless, and so this is the key, unless it needs to be used as a transmitter, in which case it will leave the cell and go extracellular. So we'll come back to that. But for now, what do the mitochondria really do? They actually have a multifaceted variety of things that they do. So initially, what we learn is about the ATP, which is, we're going to stay fairly focused and branch off slightly from that today, but the mitochondria really are our entire energy source. So we're not going to dive into the Krebs cycle, but let's talk about how Douglas Wallace, for example, Ph.D., one of the world's top researchers in the realm of biology of the mitochondria, believes that the mitochondria store energy with an electrical field of 180 millivolts of potential energy, and believes that there are over 100 quadrillion mitochondria in our bodies. So that's something that's really interesting as well, coming from someone who spends their entire time researching the biology of the mitochondria, right? Another interesting fact about mitochondria is that the highest concentration of melatonin is in the cell membrane, but second to that, the highest concentration is in our mitochondria. So I know a lot of us have been focusing on sleep and how to optimize our sleep. So that's something that you're going to want to keep at the forefront as well when you're talking about and thinking about sleep and healing your mitochondria. So the mitochondria are really referred to as the power plant or the battleship, or being in battleship mode. So when they are healthy and everything is functioning optimally, our mitochondria function in what is referred to that power plant mode, right? ATP generation and production for cell metabolism and keeping the cell functioning. But as soon as the mitochondria sense that there's a threat or a stressor, it goes into often what they refer to as this battleship mode. So this is what cell danger response addresses and explains. So a stressed cell can actually leak ATP through stress-gated panic cells, essentially, right? Or gates. So as well as other channels. Extracellular ATP, or as you might see it abbreviated, EATP when you're reading in some textbooks and things like that, it signals the cell danger response, or CDR, as you're going to see abbreviated. You're going to see that becomes initiated. So when mitochondria leave the cell in this fashion, they're being used as a messenger. So they're used for defense and communication as a transmitter. So there's two different functions of the mitochondria. It can generate energy and power for the metabolism, or it can go into defense mode and communication mode, battleship mode, as we refer to it. So this innate immunity, inflammation control, and metabolic memory is essentially how you can see that. So its two roles are inside the cell, ATP, right? Having two functions. Inside the cell, it's the energy carrier for the metabolism. Outside the cell, it's a signaling molecule, sometimes referred to as mitokine, EATP. So when the cell danger response is activated, the ATP leave the cell, and now it's a signaling molecule. So think about when you get sick. When anybody gets sick, what is one of the first symptoms that people have? Fatigue. They get exhausted. They want to go lay down. They want to be in bed, right? This is ATP leaving your cell. That's your energy leaving your cell and joining the immune, right? Joining up with the immune, right? That's why you feel so tired as soon as you get sick. So think about it like that. So as soon as there's a stressor to the body, let's say from a cut, a scrape, emotional stressors, or the common cold, like I just described, or it can actually be a whole body systemic response. The CDR, the cell danger response, is activated, right? It's activated by a stressor, according to the cell danger response theory. So in accordance with this cell danger response theory, it must complete all three cycles, which you're going to see. I'm going to pull that up here in a second. Cell danger response 1, cell danger response 2, and cell danger response 3. So this is where it starts to get actually really interesting, and don't waver from the charts, or don't withdraw when you see some of the charts and get any like high school flashbacks or anything like that. Just think about it as this continuous learning process of being really something that you can continue to grow and learn on. So I'm going to take a second here to just screen share with you. Okay, there we go. So you can see right now that we're looking at this cell danger response disorders, right? So microorganisms and toxins is what we're really looking at when we're looking at cell danger response 1 and your body moving into cell danger response 1. So I'm not going to read through all these, but I want you to be able to see the ones that are listed here, because they're going to be relatable to you or maybe friends or even family, right? So cell danger response 1, we're really talking about chronic infections, fungal, bacterial, viral, parasitic, right? And according to the literature, these processes are when the body is stuck in cell danger response 1. So I want to be clear that when we get sick and things are going on, you will move through all of those cell danger response phases according to cell danger response theory. It's when we get chronic infections that we're going to be stuck in these phases. Your body gets stuck. So we're going to talk more about how that happens and how we can move through those different phases of the cell danger response as well. So things like allergies, asthma, and as we continue to go through this, we're going to understand and start to see that, wow, this really makes so much sense. I mean, even myself with having allergies, and how did that develop, and what stage in my life did that develop just suddenly? So it becomes really interesting the more you continue to dive into this, right? So you're just going to see too, like even malaria, Lyme disease, H. pylori, things that are common that you hear about, all kinds of different skin conditions you can see over here as well. So that's what we're looking at when we're in cell danger response 1. Okay, so I'm just looking to see if there was anything else that I wanted to touch on there before moving. Let's move right into cell danger response 2. So when we look at cell danger response 2, so just skipping over there, cell danger response 2 disorders. So supports cell proliferation for biomass replacement and blastema formation in tissues with augmented regeneration capacity. So once cell danger response damage is contained or cleared, those cells need to be replaced. Cell danger response 2 is when stem cells are recruited. So this is really interesting as well. Cell danger response 2, wow, so many things that are common that we hear about as major life threats, right? Diabetes, hypertension, heart disease, dyslipidemia, you've got Crohn's, ulcerative colitis, things that we hear about so often and that we often know either through our own personal experiences or through family and friends of these disease processes, right? Let's jump over and see cell danger response 3. Oops. So cell danger response 3. I just need to move this down on my screen. So cell danger response 3, very relatable to me, begins when cell proliferation and migration have stopped, and recently mitotic cells begin to differentiate and take on organ-specific functions, right? So read that one again and then see, are any of these things relatable to you? For me, I see on the top right-hand side, Hashimoto's thyroiditis, right? So that is, I was diagnosed with Hashimoto's last year. And so that's something that I have been really diving into on a really deep level over this last year and a bit now. And really sharing a lot of the knowledge and experiences that I have been gaining throughout my entire process thus far, and will continue to share. So hopefully you see, if we've been working together, there's something that is likely going to catch your attention in either cell danger response 1, 2, or 3. Okay. And just look, I mean, autism, PTSD, POTS, PANS, PANDAS. So for those of you who don't know, PANS and PANDAS, that's really common within children, right? Then we've got chronic fatigue. It's really interesting to see the different hormone functions that change in relation to what's going on in our cell danger response theory and how that affects our hormones, our cortisol level, and therefore chronic fatigue that we see so frequently. And I see so frequently, especially in my shift worker clientele. Bipolar, schizophrenia, MS, TBI even. So diabetic neuropathy, irritable bowel syndrome. So just continuing to look at those and take this in and be able to just process this as we move forward. So going through, oh my gosh, so many things in cell danger response 3. So another thing that's really interesting is when it comes to hormones and the mitochondria. So hormones release target cell hormone metabolism and intracellular hormone signaling, which can be attenuated or reduced by cell danger response. So an organ resistance during the cell danger response can affect the major endocrine systems: thyroid, adrenocortical, glucocorticoid, and mineralocorticoid, and running angiotensin systems. Attenuation states are common in patients with chronic fatigue syndrome. So instead of thinking adrenal fatigue, like how we so often think, I encourage you to think mitochondrial dysfunction when you're thinking about adrenal fatigue, right? So once imported from the outer mitochondrial membrane to the inner mitochondrial membrane, cholesterol is converted to pregnenolone by cytochrome P450. You don't have to remember that, but if you're someone who's been studying, individuals who have been studying in even the paramedicine realm, we hear a lot about cytochrome P450. It has a lot of different important roles, right? So just back to screen sharing with you for a second here. This is something that you could screenshot and look at later. And I got this from the Cellcore presentation that I was watching on ECA. So that's where that's taken from. As a practitioner, I have access to this. If you're not a practitioner, you won't have access to the direct link. So I'm just letting you know that's where I got this from. And you can see just down at the bottom right-hand corner that that's from Cellcore Biosciences. So this is something that is really interesting if you really want to dive into the mitochondrial function. And it just even shows you what's going on inside the mitochondria. You can look right in there. So this is something you can print off. And again, don't panic when you see the Krebs cycle. I know when I saw this, I thought, oh gosh, here we go again, Krebs cycle. But you don't have to know or dive back into the Krebs cycle. We're just touching on some of the real basics here going through on the cell danger response theory, just to give you an idea and sort of that expansion of knowledge on what can be going on with your disease process, or maybe someone that you're trying to help that's a family or friend. Okay, so this is something that you can dive into a little bit further. That is really interesting when it comes to the cell danger response theory. And so here is what I was talking about. And when it's blown up, to me, it looks a little bit blurry here. So I'm sorry for that in the big format, but this is what I was talking about with the cholesterol and then going through its steps through P450 and changing through pregnenolone. And then you'll see it's going into the deoxycortisol and then changing into cortisol. So this is something that's really interesting because we hear and talk a lot about cortisol and how that's affecting our body, how that's released during times of stress. And so where that's initially initiating and stemming from, right? And seeing how the mitochondria have this incredibly significant role. So it's something that starts to go much deeper than just learning, okay, like our mitochondria play an important role. It's how do they play an important role? And we're just tapping the surface of what our mitochondria do, right? So this is a little bit different of a look. Just sometimes graphs can help people depending on your style of learning. So I know kind of graphs, charts, pictures, those kind of things for sure help me in that understanding. So you can see here, we're looking really more specifically at this middle one here, pregnenolone, and you can see how it's going through all of these different phases, right? And I know sometimes people think, oh, there's just a hormone, it's just a hormone is released, but we sometimes don't realize that our body is actually going through all of these different steps, and there are enzymes and channels opening and things happening throughout this entire process. So when we talk about the healing process, it's knowing that that's not something that's just going to switch over really quickly. It's a full process that's happening. And here we can really get a good, I really encourage you to screenshot this. I really think that this particular design is helpful in looking at cell danger response 1, 2, and 3, and seeing what's going on when we're talking about excess metabolic damage in cell danger response 1, apoptosis, programmed cell death, right? That's happening. So you're kind of seeing through these different phases what's happening in cell danger response 1. And so once your body enters the cell danger response, it needs to, no matter what, go through all 3 of these phases, right? So you can probably see some buzzwords in here that start to trigger your memory, that start to trigger some things that maybe came up from even, your time in high school, right? Okay. So even actually in that picture, we could see from the endoplasmic reticulum that was there, where you make progesterone. You make progesterone and testosterone. And you can see that while the mitochondria mediate the sex steroid hormone production, hormones can also be regulated by the mitochondrial function. So when we look at what things might be going on, and we can use even Hashimoto as an example, and diving in there and seeing how a lot of times Hashimoto's can cause things like estrogen dominance. And so when you go back and you start to learn with the different phases in the cell danger response theory and looking for even at charts that are similar to this, seeing how your body starts to convert your pregnenolone into the progesterone and moving over and moving into cortisol back and converting that into cortisol, you can see very similar things happening with all of your hormones. And so you can start to see how the mitochondrial dysfunction is going to also cause imbalances or changes in your hormones. So hopefully that's helpful in seeing how things are all interconnected, and it's not healing one thing, or it's not taking, for me, it's not about taking something, a form of pharmacology, and just trying to fill in that one void. It's understanding that this is an entire process that's happening, and that we can heal that and we can change that. But part of it is really understanding what is going on and being able to want to dive deeper and put in the work to find out where that is stemming from so that we can continue to grow. And I'm not saying that taking medication is a bad thing. I'm saying that might be something that you're going to facilitate your process in moving forward and feeling better into trying to optimize your total healing journey and root cause healing journey. So I hope that makes sense. Okay. I'm just looking and making sure that I got all those charts there that I wanted to show you. So kind of summing up that part of things with the mitochondria, it's actually about 90% of our energy that's generated by our mitochondria. So the mitochondria also stores calcium ions, right, which are needed for our muscle movements. Mitochondria dysfunction means that we're not going to be able to release or stop the calcium ions needed for muscle movement. And when you look at places that aren't getting, places like Africa that really we know don't have high calcium consumption, also have almost no rates of osteoporosis. So it's interesting when you see the different paradigms and dynamics that are involved when we talk about things on a level when it comes to pharmacology, and we talk about calcium versus looking at some of those different statistics in different countries, different places in the world that have no rates of things like osteoporosis, and looking at mitochondrial cell function. So it also forms heme needed to carry oxygen around the body as hemoglobin produces steroid hormones, as we talked about, signals the cell's time to die. I mentioned that as well when I was talking about apoptosis, and makes room for new cells. Right. And then just I tapped on there, it's about 90% of our energy that is generated by our mitochondria. So we're going to talk about some of the causes of mitochondrial cell damage. So we'll just go back to the screen share here. Once I'm going to go through this, it's right here. And so I just want to tap on this because I thought that this was really great as well from Sarah Mihail, which is organs shut down in terms of priority, i.e. the skin first, then muscles, followed by liver, gut, brain, and finally the heart, lungs, and kidney. As these organ systems shut down, this creates further problems for the body in terms of toxic overload, susceptibility to viruses, which damage mitochondria further, thus exacerbating all problems of the chronic fatigue sufferer. So I just thought that was really interesting and really packaged that together nicely after some of the things that we just addressed. Kind of puts that in a different perspective, right? Okay. Causes, was this the one that I wanted to tap on? Yeah, causes of mitochondrial damage. So we can look, there's viruses, parasites, heavy metals, things that might be really familiar if you've been working with me to what I've been sharing with you, radioactive elements, different medications, unfortunately, yes, even maybe some of the pharmacology that you're taking, right? Severe oxidative stress. What triggers oxidative stress? Pro-inflammatory and processed foods, right? We talk a lot about that. An unhealthy gut microbiome, pesticides, cigarette smoke. That was a big one, I know for myself. Chronic psychological stress, radiation, chemicals, cleansers, and deodorizers. I encourage you to pay attention to this one. I know for myself, if I'm to spray a chemical, if I were to spray Windex, I immediately get an upset stomach to the point of like having diarrhea within minutes. So I'm hypersensitive to chemicals. And that didn't start when I was younger. It was an accumulation, just as that quote we just read from Sarah here, where she says it creates further problems and become in the body in terms of toxic overload, susceptibility to viruses, which damage mitochondria further, thus exacerbating all the problems of the chronic fatigue sufferer. But this pertains to all of us, whether you're the chronic fatigue sufferer or not. This is toxic overload. That's your body's response with toxic overload. That's my body's response with toxic overload. So just hitting on a few of those other ones that I have in here as well. Alcohol, unfortunately, high blood sugar levels, right? So diabetes, being pre-diabetic, concerns around that, mold, mycotoxins, and Lyme disease. So those are a few in that category there. My computer was having a moment there wanting to just like freeze. So those are some of the things that I wanted to share in relation to cell danger response theory. I hope you were able to screenshot some of those images that were really helpful. I'm just going to go back to, pardon me, Just going to go back to screen share right now. I'm just going to click through the slides again in case there's something you missed so you don't have to rewind, and just take a quick look at in relation to getting a screenshot in if you were wanting to do that. Oops. It's kind of having moments where it's freezing here. So as you review this, as you look at some of these, the cell danger response theory chart again, in a little bit more time-sensitive manner for you to go through it, you're going to start to be able to relate this to you specifically, which is going to encourage you, obviously, to want to learn more about that as well and dig deeper. So you might not want to dig quite as deep as going into all the hormones, but you might, right? You might really want to do that. And so you can see with things in this graph in particular, where do you get stuck? Lactic acid, heavy metals, chemical toxins, right? Things like that. That you can screenshot, you can expand this maybe so that you can see the writing a little bit better, dive a little further into that. So when I think these are really interesting too, you're gonna most likely want to screenshot the one that pertains to you, whether it's cell danger response 1, 2, or 3. Okay, so I hope you found that interesting and helpful. I really just wanted to touch on the surface of that. So I hope I covered some of that. Let me know if you have any questions, if you want me to dive into this any further, or by all means, go ahead and look into Dr. Robert Noviel. I'll see if I have his name right at the beginning for you. Bob Noviel. No, this is the first slide, so I didn't put his name in there. Let me take a second here and I'll just double check how to spell his last name. It's Naviaux. So Dr. Rob Noviel. So go check him out, and I hope you enjoyed this, and we'll chat soon.